guys, welcome back to A-Level Lessons Online. We're back with our next question, question 4 on our 2016 A-Level H2 Math Paper 1. Alright, this question we're going to be looking at APGP, right, your arithmetic and geometric progression. I think it's a very simple question. All of you guys should be able to do a very classic A-Level question and question that they like to ask in exams. So the question goes, an arithmetic series has the first term A and common difference D, where A and D are non-zero. A GP has the first term B and common ratio R, where B and R are non-zero. It is given that the 4th, 9th and 12th term of the arithmetic series is equivalent to the 5th, 8th and 15th term of the GP respectively. So this one is very simple. You just need to know how your formula for AP and GP works. I'll cover this in a topical series very soon. But essentially, if you're still unsure, you just follow the steps I'm going to be going through, and this will be how you would craft the answer to this question. So firstly, we're going to look at the first AP term, the 4th term. So the 4th term, as the question has already given, is going to be an AP, which is going to be A plus 3D, and this is equivalent to the 5th term of your GP. So AP 4th term equivalent to the GP 5th term, which is going to be your BR to the power of n minus 1, which is going to be BR to the power of 4. Right, next one we have got the AP 9th term, which is going to be A plus n minus 1D, which is 8D, which is equivalent to the GP 8th term, which is going to be BR to the power of n minus 1, so 8 minus 1 to the power of 7. And last one we have the AP 12th term, which is A plus n minus 1, A plus 11D, equivalent to the GP 15th term. Right, and this gives you BR to the power of 14. So all you need to do now is that since you already have these equations, you know that the question has given you that they are equivalent. You just need to show in simultaneous equations, and from there we can start solving to find the first part, which is show that R satisfies the equation 5R to the power of 10 minus 8R cubed plus 3 equals to 0. And then we can solve that equation as well. So very simply, let's go ahead and do this. So the first equation is going to be A plus 3D equals to BR to the power of 4. Second equation is A plus 8D equals to BR to the power of 7. And last one is going to be A plus 11D equals to BR to the power of 14. So you've got 3 equations here. Let us go ahead and sub the equations into one another, right? Let's see how we can make it simpler. So if you look at the first equation, let's just use this one for guide. We'll have A equals to BR to the power of 4 minus 3D. So using this as it's going to be the first equation, let's sub the equations in, your usual simultaneous equations. So sub 1 into 2, you would have BR minus BR to the power of 4, minus 3D plus 8D equals to BR to the power of 7. So bring all the constants, okay, or anything that looks alike to one side, you would find that you'd be left with 5D equals to BR to the power of 4. Okay, you can extract to the power of 4, right, from BR7. And by a law of indices, you know that this would be added up, R cubed minus 1, right, because 4 plus 3 will give you BR to the power of 7. So this is very simply how you do it. So this would be your, let's just call it the 4th equation for now. Okay, another one you can do is when you sub the first equation into your 3rd equation. So you would be left with BR to the power of 4 minus 3D plus 11D gives you BR to the power of 14. So from here, likewise, you can combine it. So 11 minus 3 will leave you with 8D on one side. And on the other hand, you can take out to the power of 4, BR to the power of 4. You'll be left with R to the power of 10 minus 1. This will give you equation 5. Alright, so here is where you need to be, it comes with practice, okay, but you need to be a little smarter over here, right? How do we get rid of everything else but R, right? Since the equation that they want us to prove or show only is left with R. So one way we can do it is to definitely divide them by each other, because you notice if you divide them by each other, it would cancel out all the constants, right? It will cancel out everything that looks the same. So let's just do that. Let's just do equation 4 over equation 5. You'll be left with 5d over 8d is equivalent to br to the power of 4 times r cubed minus 1 over br to the power of 4 times r to the power of 10 minus 1. So from here you can see that you can cancel out a lot of constants. You can cancel out the d's, you can also cancel out the b, as well as your r to the power of 4. So you're left with 5 over 8 equals to r cubed minus 1 and r to the power of 10 minus 1. So usually APGP questions, they're all very, very similar. You just need to divide them. Okay, find a way to get rid of everything else but whatever the question is asking. So in this case, they're asking for r. You get rid of everything else but r. So you're left with all of these. So what you can do now is to just simply cross multiply. You'll be left with 5r to the power of 10 minus 5 equals to 8r cubed minus 8. And therefore, if you bring them all to one side, you can find that you can have 5r to the power of 10 minus 8r cubed. You combine your minus 5 and plus 8, you'll be left with plus 3 equivalent to 0. And this is shown. So just like this, a very, very simple way to do it. And you can easily prove whatever the question is asking. So the next part of the question, I cannot show you how to do it because you need to know how to do it yourself. I do not have a GC on this device, so you have to use your own GC. But very, very simple, right? For this part, it's just using your poly root finder. So use your GC, and you will get the answer whereby r is equivalent to 0.74. This would be your answer. So when you use your GC, very simple, right? Go ahead and use your poly root finder. Okay, and go ahead and find what the answer is. Okay, so you just need to sub in, okay, what your A values are. And once you sub in the relevant values, okay, it will give you the answer that you need, right? In this case, the order that you'll be filling up to is up to the power of 10, since the biggest power over here is going to be to the power of 10. Right? If you have a GC, you'll be able to see how to solve it, right? There's no other way to solve this, as far as I know. So this will be the first part on part 1. Oops. Okay, I can't really do that. Okay, part 1. Okay, part 2. Let's go into part 2. Part 2 is very simple actually. Alright, now it's trying to do this for me. Okay, part 2. Alright, part 2 is very simple. You just need to find, okay, using this value of r, find in terms of b and n, the sum of the terms of the geometric series after, but not including the nth term, simplifying your answer. So let us just go ahead and write out what this geometric series will look like. So naturally, okay, this part is definitely going to require you to know what a geometric series is, which is going to be, in this case, since they gave us b, it is going to always start with b, followed by br, and then br to the power of 2, br to the power of 3, so on and so forth, until we get to b to the nth term, which is going to be br to the power of n minus 1, right? Always remember it's always to the power of n minus 1. That's why our first term over here is actually b to the power of nothing, right? There's no n, there's no r over here. Okay, because it's r to the power of 1 minus 1, which is just going to be 0, which is just going to be 1. So in this case, this is going to be our nth term over here. So what comes after will be br to the power of n, right? Because it's n minus 1 plus 1. And then after that, it's going to be another plus 1. You're going to have br n to the power of n plus 1. And then so on and so forth. So from here, it's very simple. Okay, all you need to do is to find the sum, which is going to be anything that comes after the nth term. So it will be after here onwards. So your nth term over here is actually not going to be included. So that means it's going to be from br to the power of n all the way until infinity. So your answer is going to be very simple. It will just be br to the power of n, which is going to be your first term in this case, over 1 minus your r. Right, so this is your very classic, right, your a over 1 minus r method of finding the sum to infinity, right? Yeah, correct. The sum of the terms of the geometric series after all the way to infinity. So this would be how you find your answer. You just need to sub in your values now. You have b times 0.74, the answer that you found in the previous part, to the power of n over 1 minus 0.74. Just simplify this answer. You have 50 over 13 times b times 0.74 to the power of n. and this would be your answer. So quite a simple question, right? It's just using your current understanding and knowledge of what sum to infinity are, okay, what APGP is, what the formulas are all about. And once you put it into practice, you just need to sub in the relevant values. You'll be able to get the answer very, very easily. Right, so this is the answer to question 4, the solutions to question 4 of your 2016 A-level paper 1, right? Paper 1, question 4. I hope you found it simple to do, okay, because I think it's one of the simpler APGP questions, but definitely one of those that will come out more frequently and you will definitely see it more in the future. Alright, so that's all for this video. Okay, if you did enjoy or you did learn something from this video, be sure to give it a like, as well as to subscribe to the channel. It's free, it doesn't cost you anything, and if not, if you have any questions, you can always leave it in the comment section below. I will answer them, and that is about it. Alright, so if not, I'll see you guys in the next video. Have a good one. Bye bye.